Hello, let's imagine that we have 50,000 tons of liquid oil sludge in a storage somewhere. And we have to move this sludge about 600 kilometers to the nearest disposal site that is willing to accept it. However, the disposal site will only accept it if it's a solid waste, not as a liquid waste. Now, there are a few different things that we can do. And what I want to do in this very brief video is look at the carbon footprint difference between those approaches, something that is becoming increasingly relevant in today's world. Now, a method that is used to turn liquid sludge into a solid waste so that it is safer for disposal and accepted in more disposal sites is turning it into a solid waste. And the way that's done is by stabilizing or fixing the waste. And this is usually done by adding a stabilizing agent to the waste. Now, the stabilizing agent obviously has to be taken to the waste. It has to be mixed. This is usually a clay or maybe perhaps sawdust, depends where you are in the world. This increases the volume of the waste, but it does turn it into a solid. Once it is a solid and there is no free liquid visible, this solid waste will have increased the total volume of the waste by a factor of 3 or 4. This then has to be taken by truck and has to be taken 600 kilometers to our disposal site where it is safely and securely stored for eternity. Now, that's one way of doing it, but obviously we are increasing the volume of the waste by a factor of 3 or 4. Alternatively, what we can do with this 50,000 tons of waste, we can add a little bit of our chemistry and put it through our SAS mist process. And what happens there is, rather than having to add solids to the waste to turn it into a solid material, we actually remove the water and the oil, leaving only dry solids. The oil and the water will be reused, and it's only the dry solids that we then have to take and transport to the disposal site. So that's a huge saving. Rather than increasing the volume of the waste by 300 or 400%, we're actually reducing the volume of the waste by about 90% here. So the carbon footprint is going to be substantially smaller. And in the case of this particular example, you're looking at over 20,000 tons of CO2 equivalent emissions for stabilizing the waste and transporting it, or you're looking at about 1,400 tons of carbon dioxide equivalent emissions for the mist treatment process and only transporting a much smaller fraction of the waste. So the impact on the carbon footprint by actually treating at the site of storage or generation is absolutely massive. All the numbers and assumptions can be found in an accompanying download. Please do so, or you can just contact us directly with any questions or comments or any points that you want to raise or clarify on this very brief example. Thanks for your time and speak next time. Bye.